Hello all, welcome to this new presentation at LRVS EMEA 2023. Today, in this session, we're having Jan Novak, Managing Director from INTRIBO, who's going to talk about increased productivity of hydraulic machines through oil conditioning. So, thank you, Jan, for taking the time to participate, and please go ahead.
All right, so thank you for your introduction, and hello everyone, good afternoon. And what I'm going to present today to you is that how actually our company is helping our customers to improve productivity and effectiveness of hydraulic machines. I want to share with you, 30 years of our experience. Our company is placed in the center of Europe. We are from Czech Republic, and our company started as a clean tech electrostatic oil cleaners distributor, and then we adapted other technologies as well. And this presentation will be about case studies and lessons we've learned from our customers, and we are also member of Czech Maintenance Association. So this is our partner. So mission of our family company, we are not a huge company, is to help our customers increase profitability, increase effectiveness, and bring some cost savings through lubrication, because there's a lot you can save if you care about oils well. So our strategy is nothing special. Basically, what we do is that we combine oil condition monitoring with our knowledge, with technologies we have, and we educate our customers to use information technologies in the right way. We educate in the lubrication best practice, and basically that's the recipe. So I'm going to show you some case studies, but first we will talk about hydraulics. What it is. So if you look at the injection molding machine, the hydraulic schema is something we as technicians we can see a lot of components. Some of them are pretty sensitive, some valve, pumps, coolers, actuators, and other components. But one thing which is usually not visible on the first sight is oil. That oil is critical component of structural component of hydraulic machines. Without oil, it will not work. And the truth is that oil is highly affecting the efficiency of the hydraulics, the oil condition. So what we have here, we have a hydraulic system, and we also have a lot of aspects which may change the condition of the machine, which may change the condition of the oil. So there are some aspects like working conditions, environment, and many other things we should think about when we will discuss or work with oil condition. And when we talk with our customers and we start a discussion and we ask, do you have some problems with your machines? Do you have, for example, some pump failures? The answer is usually no. And that's true. That's perfectly true. And usually, pump failures, it's the very end of the hydraulics, and pump failures are not really frequent, and it may go something very wrong that the pump will fail. But so pump failures are not that frequent, but what is frequent is, for example, leaks. So on the left, what you see are just some problems which our customers are telling us that that's something they face, and they would what they see as technicians. So when hydraulics starts to leak, that's typical the first sign that there's something wrong with the oil condition. So leaking machine is typically the first thing which may go wrong, and it's obvious because seals are the softest and most harmful component of the system. So it's easy to wear seal in the hydraulics because, for example, oil contamination or varnish. Then we have pump failures, but more what our customers report is that they have pressure problems, that the pressure is not stable, that it's difficult to hold the pressure, and so on. So on the left, we see some technical basically failures we see. On the right side, what you see is that's something what see the production manager production. So the machine is slowing down, the cycle times are not stable. Someone has to go and readjust this and that quite frequently. And in the Monday morning, it's difficult to start up. There comes a lot of scrap before the production starts stable. There's increased energy consumption. With scrap, you consume a lot of energy and other things. But at the end, the managers are not happy, and basically what they see is that there's lower production, lower quality and quantity of the production, and what they see mainly are the numbers. We lose our money, we don't produce that much, we have increased maintenance costs, operation costs, and lower profits. And that is something which we are trying to change through improved lubrication. So, and it's getting actually more and more difficult, because today's hydraulic systems, they are less robust. The tanks are getting smaller and smaller with increased power, increased pressures. There are more sensitive components, shorter cycle times, and so on. So the machines, they leak less. So the oxidation stress and the stress for the oil is much worse than it was decades ago. And that's something we should consider as well in this equation. So let's go to talk about the strategy. So it was already mentioned here with other presenters that holistic approach is the right way how to work with oils in your machine. So what you should consider is is the lifetime through whole life of the oil in your company. So it starts with the purchasing, the check of the oil when you receive it, storage and handling, contamination removal, condition monitoring, and at the very end, the disposal. There's a lot of things you could improve during this whole life cycle of the oil. So let's go to some case studies. The first case study is pretty interesting one, and my favorite one. That a lot of companies in hydraulics they typically use particle counting only, and we think it's a huge mistake because this is a nice example. On the left, you have Arborg press, and on the right, you have Vattenfall. It's from a company which is manufacturing plastic tools for wall painters. And from the basic analysis, we can see that all the parameters are good in both machines, but Arborg works very well, and Vattenfall is failing. There's a lot of scrap coming out of it, overheating problems, and so on. But the oil condition looks the same, but it's not true. There's one thing missing, and that's the varnish. That's the small particles of oil oxidation products. So the Arborg doesn't have oil degradation products in the oil, so that's why it works well. And on the right, basically what we miss is that we miss large particles. So the particle count for particles larger than 4 micron is good. There's a lot of oxidation in oils. That's why the membrane patch is dark, and that's why there's a problem with the cooler. That's why the efficiency of the machine is bad. That's why valves are sticking, and so on. So this is a typical example. So one recommendation for us: take small particles into account, because varnish is not just in the world of turbines and compressors, but hydraulics, they face today, and even more today, with varnish issues as well. So this is a very nice example. With my colleague, I have visited a Japanese company in automotive, and this is what the maintenance manager was telling us about his history in the company, and that's what they've seen of the problems. I don't speak in Japan, so I tried to with Google translate it to you. So there were these main problems. These are the typical ones for a lot of hydraulic systems, and the thing is, what they've learned, because their strategy was that they were just fixing the problem. So you can say, yeah, it was the reactive type of maintenance, but they were doing a lot of proactive actions. They were changing oil. They were changing components by time basis. They tried to be preventive, but oil was not considered as a regular part of maintenance. So they were taking care for machines, mechanical components, and then the production was something what should be ensured. So they were trying to produce, and no costs were taken into account. And new machines were using more stress for the oil, more higher pressures, and things were getting worse and worse. So that's what they had. So the green line is number of machines. So you can see how the company was growing, and you can see that how many failures they've been facing till let's say year 2000, when they started to take into account oil. And what they've changed, they started to work with the oil. So the task was pretty simple: reduce oil types, so prevent mixtures, use just as low amount of oils as possible, improve oil cooling, introducing oil cleaning, using proper oil analysis, so no scheduled oil changes, and the result was fantastic. So that is, for me at least, it's fantastic inspiration that our job has sense, because such good results, such improvement, just when you care for oils. That's really fantastic. So so that was a really nice case study, and I have another one. Here you can see 3 angle machines, and as you can see here, in 2015, on the beginning, they started to have, all the machines started to have problems with iron and the analyzers. And these 3 machines are standing next to each other in one plant, and it's hardly impossible that 3 presses next to each other, they have a problem with pump or some wear. So the analysis shown us later that the new oil was actually containing iron already. So when they started to top up fresh oil and these machines, the iron content was increased as well in the machine. So that's just example how important is quality check of your oils when you receive them. So that's about this holistic approach. And another example, this is long-term condition monitoring of plant, which has several machines. So you can see company average, let's say, of contamination. We frequently use from the past gravimetry, so we measure contamination with weight of the contaminants on the membrane. But later we started to use MPC, and of course there's a particle counting. And here you can see when you start with care, when you start with cleaning, it may take several years when you get the contamination under control. But the main thing is that if you want to be successful, if you want to prevent failures, you have to stabilize contamination in your machines. And that's the key recipe for improving the reliability of hydraulic systems. It's endless story. So if you stabilize contamination in your machine, you have to continue monitoring it, because sometimes when you change the production and you have higher load of the press, maybe you run really on the edge of the maximum performance, maybe the wear and contamination level can grow. And that's something you should consider, that you should carefully continue monitoring your oils, and improve or adopt your strategy according these conditions. Another example, sometimes when you start with some older machine, removing contamination may take a couple years. Removing all the varnish, removing all the particles out of it. It's not job for a few days, connecting filter unit or any other technology just for a few days doesn't make any sense from the long-term perspective. And sometimes when you have the system, you have deposits in it, and that's some history which you have to face. And sometimes these deposits you will start to dissolve after few years of operation and care and oil cleaning. So that's also something which we've learned from our customers, that you can't stop and you have to adapt. And what we use today a lot is online oil condition monitoring. That is helping us a lot to understand, to improve our program, how to care for the machines. And basically, sensors are fantastic they are not super precise compared to laboratory, for example, but we have huge quantity of data, so we can watch the trend, and that is important for us. So this is an example that cleaning hydraulic system for 2 weeks, and you see temperature and particle counts, and you can see that the particle counts are not stable at all. And that's also a example why sampling may not be a successful strategy for measuring contamination of hydraulic systems. Because if you look on the beginning of the graph, you see low peaks and high peaks, and if we will take sample here, maybe the contamination level will be considered as good, and there will be no filtration involved in that. So and the reason of it and that's something we learned a lot from our customers, is that the contamination is not evenly dispersed in the whole machine. It's coming, let's say, in clouds. It's coming with load, and hydraulic systems, they operate it with cycles. So sometimes some pump starts, you start cooling, and you have short shutdown, and so on, and getting up and getting down, and getting up, getting down. And you can see that filtration was successful, because the trend shows us that we are going in the right direction. But sampling is something which can be considered as not really successful in this case. And this is another example, and that's how online condition monitoring should work. Here you can see a press which operates just during the day, 5 days in a week, so it's not constant load. And you see that also, in the day, the contamination starts at ISO count 18, 15, 12, something like that, and slowly gets down 2 or 3 classes later in the afternoon. But what we see from the trend, that the contamination day by day grows. So, and this should be considered. contamination grows. So we should do some maintenance action. And that's the reason why customers should have online condition monitoring, because having just the data and not using them is just wasting time and money. So here you can see example, all right, we found out the contamination is just too high. We should consider some action. And there you can see that, yeah, contamination level was finally at the control. All right, 5 minutes to go. So another example, may oil change go wrong? This is a hydraulic press with 9,000 liters of oil. There's some offline filtration installed with 12 filters, depth media filters. And this is the oil analysis. So I will zoom it. So basically the oil is heavily contaminated. There's a lot of particles. You can see also a lot of oil oxidation products, but basically the oil condition was good. So they decided to change the oil, and so they cleaned the tank, they disposed the oil, they lost a couple of days of production, and this is the oil analysis result few days after the oil change. And basically you can see here that, yeah, it's not helping too much, because if you clean the tank, you will keep the contaminants in your machine. So everything will dissolve from the machine, and basically you will destroy your new oil. So that's not the right strategy. Good thing about that is that, you know, new oils full of additives, they are very easy to clean. So after several days of cleaning, we came to that result, and the system was clean. So that was good. But when you have contamination in your system like that, you know, that's hard to remove. And there's a new tool for us. That's the solubility enhancer. So here's an example that you can see here on the analysis that we applied the solubility enhancer, and the MPC level from 45 within just few days dropped to MPC 15. And what is the most important thing is that the machine was reliable after that. So no problems with valves, no problems with quality. So that was the most important thing about that. And another example, online condition monitoring. You know, sometimes we can see some weird things. We clean oil, we see contamination drop and increase again. And why is that how is that possible? That, you know, particles with filtration or cleaning, they went up, and that is something we should take in the part that is the temperature. And you can see that after a few days, when the temperature of the oil dropped to, let's say, 30 degrees, we can see a huge increase of particles. And that is the varnish. Okay, time is coming. So that's telling us that we should change our strategy. That there's a varnish, a lot of varnish in the system. Yeah, and finally, good example here. We have here a large press, hydraulic press in automotive. And here at the end, you can see some increase. Water, contaminants, degradation product, the MPC growth. And what happened? Actually, what we've done with that. There was a problem with water ingression, with contamination ingression from outside. And what we did, that we did the ruler test, and we found out that basically the oil was not protected against oxidation. That's why we see a lot of huge growth of oxidation products and problems with the MUG valves, which are very expensive. So we've done a compatibility test with additive package, and that test was successful. So that we were sure that adding additives in this oil will improve its condition. And so we increased a little bit the capacity of for the cleaning of the oil, and we added the additives, and we nicely stabilized the oil condition and mainly stopped the problems of the machine. So that's great tool, next to others I presented today. So I'm at the end of my presentation. So giving more money for the maintenance, giving tools to your maintenance team will highly improve your production loss and highly improve efficiency of your hydraulic systems. That's the message from me. Thank you very much for your attention, and if there are some questions, I'm ready to answer.
Yeah, thank you very much, Jan, for your presentation. Very complete, very interesting. So unfortunately, we're running out of time, but you can submit your questions through the system, and then we will Jan will respond those by written answer. And you also remember you can access this through the learning platform. So thank you very much for all the attendance, and thanks again, Jan, for this very interesting.
Thank you. Thank you.
Thank you.
Bye.
Bye.